Hey, welcome aboard.
Hey, hi, how are you?
Doing really, really well. I am so stoked to chat with you. We don't have to call this official kickoff or anything, but I really
Okay.
appreciate you taking a look back at some of your previous work, and I want to talk about stuff that you're looking forward to as well. It's just that your book was a whole lot of Venn diagram overlaps to stuff that I'm fascinated with. So was working my
Well,
way through and was like, I have to talk to this guy. So there we are.
thank you very much for reaching out. I look forward to our conversation. I'm very curious and intrigued how this conversation is going to go. And that was the main reason why I'm here. So I look forward to that, Jonathan. Right?
Outstanding. Well, I've blocked off about an hour and a half. No reason for us to take that much time if you've got other things to do. So I usually aim for about an hour's worth. I just
Yes.
figured that we might get into some really weird territory, and just to give you the space so you don't have to cram too much in, but also I want to be respectful of your time so that if you've got to head out, then we'll stick the landing.
So I have to be honest with you, Jonathan. In 1 hour's time, my wife will have prepared some burritos for the family, and it's just something that is just too much to say no. Okay, so that
Beautiful.
that's my reason. All right.
It's good to know that you have good priorities. So to
Priority number one, food. Okay.
amen. Amen. So to that end, if you would introduce yourself so that way we get it exactly right, and we'll call that the beginning.
Okay. So hi, Jonathan. Hi, everybody. My name is George Zarkadakis. I have a doctorate in artificial intelligence. I've been working in the field for a long time. I'm currently senior fellow at the Atlantic Council, which is a think tank in Washington. I'm also leading digital innovation for Willis Towers Watson, which is a large consulting company. I'm also a writer, an author. I write fiction and nonfiction. The last few years, I've published two nonfiction books, one with Penguin a few years back called In Our Own Image, the history and future of artificial intelligence, that I look very much forward to discussing with you today. And more recently, about a year ago, I published a book with MIT Press called Cyber Republic, Reinventing Democracy in the Age of Intelligent Machines. So thank you for the invitation. I look forward to this discussion.
Yeah, I am really excited to have you on board. One of my mentors, I took debate every semester in high school. I used to be a really shy kid, and I think almost entirely in pictures. So it was difficult for me to translate my images into words that other people could understand. And my debate teacher said, if you want to take anybody anywhere, you have to slow down enough to get them in the car. Your book is all about AI and cutting edge technology and the nature of consciousness. So you go all the way back to caveman times and the creation of language to talk about something that is still in the future for us. So walk me through what drove you to writing a book about AI, and when you realized how far back you had to go to give people enough context to understand what in the world you're talking about.
Sure. I think there were two moments that kind of combined to have me think of that book. One moment was, and I've described that in the preface, it was in Tucson, Arizona. I was taking part in a conference there from the University of Arizona, which was, the conference was biannual. It was called Towards the Science of Consciousness. Okay. And it attracted different people from different fields. You get philosophers, biologists, system science, computer science, Buddhist monks, you name it. Okay. Which is really interesting to get all those perspectives. Anyway, so at the end of the conference, as conferences go, there's a dinner. That particular dinner happened at the was it a zoo or something like that? Beautiful, beautiful place just outside Tucson, you know, where you could actually touch the animals. So it was a beautiful sunset. You can imagine the scene, idyllic. And I was sitting at a table and we're discussing consciousness. The conversation kind of like drifted to data, commanded data on the Star Trek. And suddenly, instead of discussing this sort of scientific things around artificial intelligence, we were just geeking out on all the movies and the books. And that kind of like struck me, okay, wait a minute. maybe that's why we're here. We're here because many years ago, right, we watched all those films and we had those stories. And there is something about the stories that kind of like motivate young people, young men and women, kids, to follow science, right? And if that's the case, then why is that? What's in the stories that make us want to invent things? What's in the narratives that drive science, in other words? So that was like a big question. And then I follow up this kind of like eureka moment with another eureka moment, which was, you know, artificial intelligence, and everybody's talking about artificial intelligence now, but it's been for a while, it's been like 60 years since people have been trying to do artificial intelligence. And of course now, you know, most people kind of like more focused and more humble about what artificial intelligence is supposed to do, automating tasks, science, But the original idea about artificial intelligence, an idea that has not left us, by the way, is how we can create an intelligent machine, as intelligent as us, ultimately a conscious machine, right? Something that is us, but in a different body, okay? That is the core idea, the holy grail of artificial intelligence, still is, okay? And then I thought, why do we want to do that? I mean, why? You know, I can understand why we want to build airplanes and spaceships and submarines and computers. You know, I can understand but why exactly do we want to build us in another form, right? That's, I mean, what's it? So that was the second question. So with those two questions, I went away and tried to seek answers. Okay, for example, what is it about the human mind, about our cognitive system, about the way nature put us together that wants us to build things that look and behave like us? All right, where did this thing come from? Okay, what are the origins of that drive? Okay, and you don't need to wait for the 1950s to see that drive manifesting in the quest for artificial intelligence. That's what I've discovered. You know, this drive to project who we are, our minds, our hopes, fears, the bad things about us, the good things about us, everything about us onto artifacts has a long, long history, right? In fact, is as long as the human species itself. Okay, and that is why, perhaps strangely, perhaps paradoxically, I begin a book about artificial intelligence with the first artifact that has been discovered, that lion man, that little sort of ivory statuette that is discovered in Germany, which is like 40,000 years ago, I'm sorry, all right? And all about the so-called Big Bang of the human mind, which I think it's an amazing idea, right? And it's, you know, we're still trying to explain that. I mean, what happened? Because as a species, we have a 200,000, maybe 300,000 history behind us, evolutionary history, right? We see, you know, modern humans, you know, being around for 300,000 years. And yet, only in the last 40, maybe 60,000 years, and that happened across the world, not just in Europe, you see that in, you know, in Asia, elsewhere as well. Something happened, right? And our brains kind of like changed, okay? And we know that because of art, okay? Suddenly, you know, those ancestors of ours thought, okay, you know what? I'm not going to go out and hunt for food. I'm going to just chill out here and just build, you know, this beautiful, in the cave, and just draw these beautiful things, right? For the joy of it, okay? Right? I mean, this was amazing. Okay, so I don't want to go on and on, Jonathan. I want to give you the opportunity to ask me something as well, but just to wrap this up, you know, and then I realized that there is a reason for it. There is clearly a reason for it. We know why. We know why, and the reason why is something called theory of mind. That's the name. That's how we call this ability of the human cognitive system at about the age of 3, right? When we realize suddenly that other beings around us, our mother, father, you know, siblings, even the dog or the cat, if we have one, have minds of their own, different than ours, right? That's called theory of mind. We don't know if we have minds. You don't know if I have a mind, and you can't. Unfortunately, you can't make. There's no way you can check it, right? I can be a zombie. I can be a virtual person. I can be an AI right now, and so may you, right? We have no idea of checking each other out, by the way, right? But instinctively, I feel that you're a human sitting opposite me right now, and that you have mind and emotions, and that's what makes me communicate with you. That's, you know, how we connect right now. So that's called theory of mind. And that theory of mind is at the root of just about everything that is good and bad in humanity, because it's all about manipulating others. It's all about becoming a social being, right? For better or for worse. For better, let's think about theater, for instance, right? We sit in the theater on stage. There are some people pretending to be somebody else, right? They're telling us a complete lie, okay? And yet we're sitting there, and if the play is good and the actors are good, we'll start crying or laughing, or, you know, we believe everything, right? We know it's not true, but we believe it, okay? That's theory of mind. And that makes us better, okay? And then on the other side, you have, you know, Goebbels, right? Nazi Germany, manipulating millions of Germans to hate the Jews, for instance, right? Okay, that's, you know, that's what I mean about, you know, the good and the bad. Okay, but
Right.
it's the same mechanism underneath everything else, everything that's just described.
I love that, because one of my friends said that stories are our original information storage and retrieval devices. That's where we put our principles, that's where we put our lessons, and then we would pull them back out by telling stories. So stories are some of our most ancient technologies. And another one of my friends and kind of mentor said that shamans were back in the day when science, philosophy, and art weren't separate things. They were all together. And that nowadays, magic and magicians and mentalism is an environment where those three things come back together again in a way that you don't find anywhere else. And when you're talking about theory of mind, what I do as a mentalist only works if you've got theory of mind, which is why children aren't impressed by a mind reading show, right? So you have to have enough experience to understand, oh, reading minds shouldn't be possible, but here's this guy that can seemingly reach inside my head, which helps bridge that gap of, I'm not sure you're real. I'm the only one locked inside my head, and I can't know for sure that you exist. Then here comes along a mentalist that can seemingly bridge that chasm. And it's such a powerful experience for people to just be seen and going, wait a minute, there's at least one person that knows I'm real. I can take that to the grave with me. And that's why I get paid a lot of money to do what I do. And it all boils down to that thing that I think people are trying to recreate by creating something artificially intelligent to prove to themselves that I existed and I was here. But I think it's all stuff that's been figured out from the Pythagoreans, and we're all just playing out the same conversation. So I wanted to kind of take you back to that, because in your book, you touched on the nature of whole numbers and the beginning of connecting mathematics and logic as representations of the same kind of thing. And I don't know if enough people appreciate just how devastating irrational numbers were. And I think that that's still at the heart of the AI conversation too, because as you're saying, it's all fundamentally, is intelligence computational? Can you compute it? And I think the Pythagoreans figured out that you can't, due to the nature of irrational numbers. So I wanted to kind of turn your spotlight to that for a little bit.
So let me try to unpack a few ideas, right? Because there's a few ideas that's kind of like fused, but let's try to unpack them. So let's start with artificial intelligence, right? Since this is perhaps the main topic, let's say. Now, there are two schools of thought in artificial intelligence, right? And the difference between those two schools of thought is about the question, how is knowledge about the world represented in the machine? Okay, how is it represented? How does the machine know about the world? Because knowledge is very important, because once you got the knowledge, then you can take decisions, you can take actions, etc., etc. So knowledge is at the heart of that. And how you represent knowledge is very important. So one school of thought called the symbolic school of thought, which had been dominant for many, many decades and is not dominant anymore, it's out of fashion, says, you know what? The machine should create a symbolic representation of the world, because really that's how humans do it as well. And that school of thought is based on that long history in philosophy and mathematics, starting back from the Greeks, where, and the Babylonians, where they started using symbols in order to represent concepts. And some of the symbols were indeed numbers, right? And as soon as the numbers were discovered, the big question was asked, what existed? Did the numbers exist before the things that you count, or the numbers exist because you count things? Okay, so this debate has been going on for the past 5,000 years, by the way, Jonathan. And you have camps supporting opposite views, right? So you have on one view, the so-called Platonists, let's say, right? The numbers, the abstract numbers, pre-exist everything else. Okay, and this idea is very powerful. This idea is all about the idea that mathematicians have. So the mathematicians, when they come across new ways of thinking about mathematics, they call about mathematical discoveries, right? They use the word discovery. And that means that the mathematics pre-existed. They're somewhere, they're out there somewhere, hiding. And then, we kind of like shed some light into the darkness, and we discover real numbers, we discover group theory, we discover set theory. So that means, because numbers are non-material things, right? The number one is not made out of atoms, not made of energy, it's not made of nothing, okay? It's out of this universe. So you have this concept that perhaps the whole universe is a projection of something else, something that's outside the universe, okay? And that's a very interesting concept to explore, okay? So the symbolic school of thought in artificial intelligence adopted that approach, all right? That approach is that we can understand the world through symbols, through logic and logical operations, okay? Now, the other school of thought, which belongs to the same category with the people that believe that you need to have things to count in order for numbers to exist. So the number 2 does not exist unless I have 2 things, I don't know, 2 rabbits, 2 cows, I don't know, 2 problems, I don't know, something, okay? And that's how numbers came to be, because I had to express that. So that school of thought is very much closer to the hard scientific school of thought. That's the empirical school of thought, if you like, that says, okay, I can only know things that I can measure, right? And because I cannot measure anything outside that universe, I cannot measure things that are not electrons, not quarks, not energy, that none of the above, then all those things just simply don't exist, okay? Because I can't measure them. That's an empirical school of thought. So that broader scientific school of thought called empiricism, okay, represents that second school of thought within artificial intelligence that looks into how knowledge is represented in the human brain and says, you know what, I'm going to try to mimic the structure of the brain. So the brain has a certain structure, has neurons communicating with each other. So what I'm going to do is I'm going to take that and put it into the machine. And that's the dominant school of thought right now in artificial intelligence. So yeah, when you hear, for instance, that you have face recognition, right? So you have a machine that can see and say, hey, Jonathan, right? Okay. The way it does that, it does because it's based on a technology called neural networks, artificial neural networks, and those artificial neural networks are based on a concept about the neuro biology of the human brain. Okay, I hope I haven't confused you and confused everybody, but really that's what's at stake right here. And the reason why I'm trying to explain like that is that, you see how far we have to go into the future to really understand what's happening today. And I think we need to do that, right? Because it's all connected and it's all relevant. So you see the debates we have, for example, in cosmology, okay? Shall we, for example, accept the fact that, we live in a free miracle? By that means that we don't have to explain Big Bang. It happened. We can explain everything after the Big Bang, and that's fine. Yeah, but why did that thing happen? And why is it was so finely tuned? You know, I mean, that begs for an answer. But unfortunately, we can't answer that unless we can measure what happened before the Big Bang, at least in empirical science. Okay, and then you have, for example, in the same space, and I'm shifting gears towards cosmology right now, just to make a point. You have, for example, string theory. Okay, so string theory is a purely mathematical theory that explains the universe, but it explains in a way that you have to accept that there is another type of reality, you know, beyond space and time, in many more dimensions, right? That is purely mathematical, okay? And out of mathematics emerges the material universe. This is exactly what Plato and the Platonists said, and, you know, Pythagoreans before Plato, right? So this is the tug of war, if you like, in Western philosophy and Western science, you know, since the dawn of time, and definitely since the dawn of Western civilization, right? And what the point I'm making in the book is that this is a unique thing about Western civilization, right? We are the ones that suffer from that schizophrenia, right? Okay, if you look at other great civilizations, you know, in China, elsewhere, they don't have that problem. Okay, so is this good? Is it bad? Well, I think it's a little bit good and a little bit bad. A little bit bad is that we're always unhappy. A little bit good is that we constantly innovate great things, right? So anyways, but that's a different conversation, right? But anyways, I'm trying to kind of like unpack those concepts, because I think for me they're very interesting, how everything connects, right? And it makes, I think also, it is also very important for us to understand that, because we are faced now with several ethical questions around the use of AI, you know, the use of data. It has social implications, and we can't really find solutions for the social implications of artificial intelligence unless we understand as clearly as possible what are the fundamentals, what drives this technology, where does it come from, what is it trying to do? Why, for instance, you know, we're talking about machines as being autonomous, right? Autonomy is something that we understand as a human quality. You know, you and I are autonomous beings, at least in a democracy, and that means we have free choices. You know, and our freedom is only limited by the freedom of others, right? But until that point, and that's, you know, very broad, we can be whoever we want, all right? And that's great, but that's human. But we build machines in the same premise. Is it truly what we really want to do here? I strongly doubt that we want to build machines that can do whatever they like. Okay, all right, that seems to be very dangerous. But anyways, let me pause here and turn it over to you, Jonathan.
Yeah, the question between ideas bear fruit to material reality, and then material reality is the substrate for ideas, seems to be the kind of fundamental divide. And that reminds me of Buckminster Fuller talking about most of life is metaphysical. It's the patterns above the substrate. Overhand knot is an overhand knot, whether you're using nylon or a straw wrapper or a blade of grass, it's still the same thing. So how does meaning fit in as a pattern for material or ideas within that framework?
Yeah, you know, I wish I could answer that, but let's discuss it, right? I'm afraid I don't have the answer, right? And I think that's the, you know, if Big Bang is one great mystery, right? Because that's kind of like pushes our, not just our minds, but, you know, the approach we have into understanding reality to its limits. The other big mystery is, you know, how does a meaning emerge? Okay, which is really, how does consciousness emerge? Okay, and I mentioned right before, you know, that I was going to Tucson every 2 years trying to find that answer, right? As everybody else. You know, nobody has, by the way, right? There's people working, okay? And again, you see in that, you know, in that scientific field where many different sciences are trying to understand consciousness, okay? What's going on, for instance, and when you put a mirror in front of me, I see myself, I can recognize myself in the mirror, right? So I have a sense of who I am. I know who I am. I can, and you know, you can see other animals do that as well. We're not the only animal. Obviously, you know, primates do it, dolphins do it, maybe other animals as well, maybe some birds, octopuses, which by the way are super intelligent. So what's going on, there? Is it, for example, and at that question, Jonathan, remember those two schools of thought, the Pythagorean Platonic school of thought, that consciousness is not a quality of the physical universe, but maybe the physical universe is a projection of consciousness. Okay, which goes back also to Oriental philosophy. Oriental philosophy is very similar to Plato. Let's call it that way, right? The difference with Western civilization is that we also had Plato's, opposite number, which was Aristotle, which brought this idea of empiricism into Western philosophy, and then was taken up after the Middle Ages and became the dominant school of thought in the West, in Europe, and brought the scientific revolution. Okay, so you have the Plato, and then you have the Aristotelian, let's call him that way, empiricists that say, hey, you know what, guys? It's the brain, it's the neurobiology of the brain, it's the way, things connect that creates meaning. Okay, so you have this tug of war. Okay, and for instance, in one school you have, some really, brilliant minds like Roger Penrose, for instance, right? Won the Nobel Prize with Stephen Hawking, great mathematician, who thinks that consciousness is in fact at the very fabric of the universe. And when he says very fabric, because he's a mathematician, he does speak about something that exists outside physical reality, right? He talks about equations, mathematics, that have physical effects, right? So he talks about the collapse of the wave function, which is scientific speak that says that, things can happen, all things can happen. Some things are more probable than others. And because of that fundamental property of nature, which if you think about it, is kind of crazy, right? Because, we don't have experience of that in the real world, well, not really, and because of that, we have consciousness. So going back again to the artificial intelligence story and the robots, and going back to the stories of robots, which is also something that I'm exploring in the book. We have all those robots, from the 1920s onwards. You have like Metropolis, the film, Jeff Lang's film with Maria, all right? But before that, you have, Mary Shelley with Frankenstein. You have many, many stories where humans create those artifacts, right? And they create them with various means. They might be using mud, or they might be using some other thing. But as technology progresses, the paradigm shifts as well. And now we are at the point of civilization where if we think about an artificial human being, we'll probably build them like Elon Musk showed everybody. I think he was a bit gimmicky there, but I love Elon because he is exactly that, right? He's pissing everybody off. That robot, it was an actor, it wasn't a real robot, but that's how the robot will look like. So it has mechanical parts and bits. So again, when we think about these artificial beings, we really think of them as a version of us, right? Okay, and all the great films about robots and androids and whatnot, they pose that question, that key question. So if you build something that is perfect human in every way, right? If you are the creator of an artificial perfect human, how do you know that you're not one yourself? Okay, all right. That is the paranoid idea that runs throughout Philip Dick's novels, for instance, right?
Mm-hmm.
And I think paranoia is at the heart of that story. Okay, that is paranoia is at the heart of the story, whether it manifests itself in that question or in other questions. So for instance, am I being? Is there a surveillance, right? Is the government checking me out, or is it some corporation checking me out? It's all about paranoia, right? So in artificial intelligence and paranoia go hand in hand. Okay, that's one of the conclusions I'm reaching in the book. Okay.
Yeah, that was a thing that impressed me going through the book, is the way that people categorize things tends to reveal a certain amount of intelligence. And you kind of packaged it all up in a fear and love narrative. that Metropolis is the story of fear, of power, of a whole lot of things played out through the just a gorgeous film. It's my dad's favorite movie. And then being able to see that love-hate dichotomy play out, that's the nature of it. And then second is your recognition of the 6 epochs of technology as storytelling for us to relate with science and innovation, starting with clay tablets and then the pneumatics and phlegm and fluids and chi, then to clockwork and electricity and that kind of thing. It's really interesting that you brought up Elon Musk too, because he points to reasoning from first principles. But we understand things in narrative form. So we're telling ourselves the story of what technology is. Oh, the human mind is like a computer. Your conscious mind is like the RAM and your memory is the storage. And it's exactly nothing like that. But it's a useful analogy. But when you're reasoning by analogy, you're way off the mark, to use an analogy, and you're building in the limits of what you can understand. But then when you look at first principles, the emergent details of meaning aren't there. You can't measure it. So it's that kind of weird Gödel's self-referential incompleteness theorem just borne out. So where do you go from there then when you realize that there's a chasm at the bottom, so there's no support, so where do you go from there?
So Jonathan, I think, that the real challenge is that all those metaphors that we use in order to explain stuff, right? And you mentioned all those phases that I'm sort of looking into the book, and let's fast forward to the present, where because computer technology is the dominant technology, right, and it's so much embedded in our lives, we use a lot of the parts of that technology as instruments, as words to express other concepts, including the human mind. Okay, so this is a very mechanistic way of thinking, and I think, in the beginning it was just wordplay, I guess, innocent wordplay, right? Someone thought about, oh, that's a nice metaphor, I'll explain that way just for fun. But words are very powerful, and wordplays are very powerful as well. And in fact, most language is wordplay anyways. And that means that it conditions our thinking. It sets the boundaries in our thinking. And that has always been the problem with human thinking, okay? And that was the problem of philosophy, at least some parts of philosophy, since ancient Greece. How can we examine our thinking processes? How can we test that what we think, the way we think it is stands to reason or not? Okay, how can we do that? The problem that I see right now is that our society doesn't really have a lot of self-reflection. Okay, doesn't I think we live in crazy times. I don't know, maybe we've always lived in crazy times, and there have been crazy times in the past, but I think we have returned to a kind of crazy time now where anyone can say anything, right? And there's no self-examination. And we can discuss why is that. Like why, for example, we have things like Twitter. I mean, how much can you express in 140 characters, right? I mean, the really important things in life need years to explore and explain, right? Emotions, friendships, love affairs, bonds that take years to grow, right? We're not machines, okay? Certainly not, but I think more and more people are trying to imitate the machine. Okay, that's what I think. That is perhaps, that's my 2 pennies, right, of social philosophy here, that we are suffering from that metaphor so much that we pretend to be machines. For example, when we are trying to debate something on Twitter, right, this is not a human way to debate things. That's a very inhuman way of debating things. That's like machines, just tweeting at each other kind of thing and exchanging messages very fast. And this is a mechanical algorithm, which is used in computer science, by the way, right? But it's not applicable to human society. And we see that clearly because the end result is everybody getting pissed off, right? Rage is the end result. We're all angry at each other. Oh, yeah. Because, yeah, that's not the way people discuss things, right? They sit quietly, something, maybe they have some meal, have a little drink, they know each other. I disagree with you, but I respect you. I know you're a good fellow, right? So I'll sit down and listen to you. You listen to me. We don't have to agree, but we have a good time, right? And that's the human way, okay? All right, so to go back to your question, I think what I would suggest is that computer engineers, computer scientists, scientists of all forms, entrepreneurs, take some time off to read a little bit of philosophy. Okay, I've heard time and time again from very respectable scientists and engineers, I don't need philosophy. What's philosophy? Philosophy is this fluff. Okay, come on. What have philosophers done for us? Show me something that I can use from philosophy, and if you look around, there aren't many things, we have, things that are built by engineers mostly, you don't have like using a philosophical thing. Yeah, but philosophy is what drives everything. That's what most of these guys don't understand. The fact, for example, that we have a certain way of thinking around engineering is because of empiricism, is because of Aristotle, and if you don't examine that thought process and you just take it for granted, up in a very mechanistic interpretation of your world that is good in order to build startups that have high valuations, but I don't think they're good enough to make people happy and create a society where we can thrive. Okay, it makes a society that is paranoid and full of rage. At least that's my take on it.
Yeah, for sure. I've proposed a new Turing test of intelligence for AI being a creation that can design and execute a magic trick that fools and entertains. Like that's pretty good theory of mine in my book, because using just words, I can stand on stage in front of 1,000 very intelligent human beings using exactly the same script. The person on stage, my volunteer, is experiencing a demonstration of phenomenal memory. They're going through an experience that they interpret to mean, wow, Jonathan's memory is world class. I am seriously impressed. Then the 999 other people that are out in the audience are seeing a psychic demonstration. There's no way that Jonathan could understand what that volunteer is thinking. And then there's me. I'm seeing it unfold in real time because I wrote the script, I designed the entire experience. And then there's the fourth dimension, which is the physical reality of what's happening. But there are so many layers of meaning from exactly the same experience that it is tough to be able to reduce it to ones and zeros that are quantifiable. So you're right, trying to behave as machines that are bounded to computation is a really poor strategy for being a human.
Oh, so, absolutely. I love your Turing test, Jonathan. I think, that is a real Turing test for machines. So I do a little bit of playwriting myself. And, when you write a play, you use a lot of what is called intentionality. Try, in intentionality, you have various degrees of intentionality. For example, first degree is, I know that you know, okay? So we can play something where we pretend that you don't know, but I know that you know. The audience knows that you know, and that creates for something interesting, right? Then second degree, you know that I know that you know. Okay, and then we can use that to make an interesting dialogue, and then third degree and fourth degree, right? And we play around with that, and human minds are built in order to understand those intentionalities and enjoy those intentionalities, actually. And great plays and great novels, but mostly great plays, are based on that play, on that game. Okay, all right. Someone walks on stage, and the audience knows that they are the murderer. There's another person on screen that doesn't know that the guy is the killer, right? And you automatically you can predict the emotions, right? Okay, that's happening because he doesn't know what he is, but you know who he is, right? So all these games. Now, for this to happen, you really need to have whatever it is in the human cognitive system that does it, right? And that would be an extremely important test for conscious machines. Now, right now, nobody's talking about conscious machines, although, well, a few people do, but the mainstream is not that we're going to build a conscious machine. What they are trying to build is what they call general artificial intelligence. Okay, so general artificial intelligence is a timid way of saying I want to build a really intelligent machine that probably might have consciousness. We don't know, but we don't want to touch that, right? Because nobody knows what it means. But general artificial intelligence, what it does mean is that you will have something in front of you which is not human, and you will enter into some kind of relationship, dialogue, whatever, with that machine, and you will not be able to tell whether that machine is human or not, which goes back to the Turing test. Okay. Now, the latest example of that is something called GPT-3. I don't know if you're familiar with that, right? Which is a natural language processing system, essentially a system that has read everything that exists on the web, just went there and just sucked everything up in, right? Okay. Something that will take me and you a few billion years, right, to do. It did it in a few hours. Okay. That's the amazing thing about computers, right? And it just sucked that in, processed that in. And now it can write things up. It can, it can write little short essays, perhaps, right? And that's how things will progress. There's other iterations of that machine, which are higher and higher, and people are making more and more of machines that are very intelligent, right? You can have a dialogue with them. You can ask them anything you like, and they will tell you, right? That's why Google is investing on that, because you're not going to have just, search button with keywords. You can just ask the machine, anything you like, and the machine will just talk to you, right? You will have a friend, okay? This invisible friend. I don't know, it's a little spooky, right? But maybe the friend will guess what you want, okay? Because of predictive analytics. And by guessing, maybe it can simulate that first level of intentionality, right? Which is, I know what you know, meaning I can kind of like predict, because it's a prediction problem ultimately, that you probably want something right now, and before, you don't need to tell me, Jonathan, here's a picture of, I don't know, whatever, okay? Because that's what you wanted, right? Yes, okay, got you, okay? You see, I can read your mind. We will have that kind of relationship with them. We already have them, if you like. There are predictive algorithms that can do that. Mm-hmm. And that will play very well with that first level of intentionality. I think that's going to be covered pretty quickly. But at higher levels of intentionality, the ones we just discussed, the ones that are evident in good plays and in life and whatnot, I think that will be very challenging for the machine. That requires theory of mind, that requires ultimately consciousness. So in conclusion, artificial intelligence research will pretend that it doesn't want to know anything about consciousness, will go down the route, and at some point, it will reach a point where consciousness, artificial consciousness, will have to be discussed and debated. Okay, that's my prediction for the next 10 years. Let's say, right? Nice. We will have to touch on artificial consciousness.
What's your gut reaction when you see AI sprinkled on as marketing sauce? AI powered real estate listings and that kind of thing, where it's the new hotness. How professionally insulted are you when you see that?
Okay, so I think this is a fad that will pass, right? We're just going through this sort of, annoying period where everything is AI, okay? But if you look back at, the previous industrial revolutions, right? Whenever we had like a hugely important technology, what the economists call a general purpose technology, a technology that is fundamental to everything else. For example, steam engines, okay? Electricity, computers, right? you will see, let me take electricity. When electricity was kind of like invented, everybody wanted to tell everybody that they're using electricity, right? Okay, everything was electricity. Electricity was the new god, okay, and it was all everywhere, right? Now we're all very excited with this AI thing. The reality is that AI embeds itself in just about everything. That's what general purpose technologies do. So AI will be in everything, right? Well, in everything that has a chip in it, okay, some kind of electronics. And, maybe 2 years from now, we're not going to be talking about AI anymore, right? It will just be, part of the fabric of society, right? But now we are at this stage, like it's the teenage years, right? Where we discover sex or something, right? Where we think, oh my God, sex, okay, well, let's talk about it, okay? After a while, you don't want to talk about sex so much, right? Okay, so now it's the period that we talk a lot about sex / AI.
Love that. My favorite little bit of trivia around electricity is Triscuits, the crackers, right? The name comes from electricity biscuits because they're baked with electricity, and that's how they came up with the name. So Triscuits are electricity biscuits.
Amazing. So there you go. At that time, they wanted to say that the biscuits, which has absolutely nothing to do with electricity, somehow was baked with electricity, right?
Exactly.
Okay? And therefore it was a superior product, right?
Right. Cutting edge technology.
There you go.
So at near the end of the book, you were talking about how intelligent systems and better predictive capabilities can help compute really, really tough problems like marketplaces. Marketplaces are a distributed computational issue where every person is kind of doing their life math of, does this exchange make sense or not? And having a handful of people as a communist or socialist dynamic has central planning, the inputs alone are too limited to have enough knowledge to compute what should be done in a predictive way, which is why those centralized systems are so out of touch with resource management, why they just simply can't work. And then with AI and really, really good intelligence, what's your vibe on that front? Are you looking forward to computer run communism? Are you looking for computer run democracy where we all vote on what flavor computer is going to run our government? That's kind of looking to your other book. So I wanted to give you a chance to kind of crack the door on those ideas.
Absolutely. And what a wonderful question. And indeed is the subject of the second book, although the ideas start in the first book. So let's start with a little bit of history, going back to the Cold War. Okay. Then you were probably a kid then, Jonathan. Yeah.
I remember the Berlin Wall coming down.
Okay.
But I was very young. It's a very early memory. Yeah.
Okay, so it was an interesting time because you had two completely different economic systems competing, and one was communism, where the idea was that the economy could be run centrally from the center. Okay, so the economy could be run in a way that the center could predict what people needed and give instructions to the productive means, the manufacturers, the factories, to produce what the people needed, and that's how the thing would be done. Okay, and on the other hand, you had the free market economy that said, okay, we'll let the markets decide where demand meets the supply and fix prices. Now, what the communists were trying to do is not so crazy. There is something called the socialist calculation problem. And in a nutshell, what that means is, can we put together a set of equations, linear equations in that case, that can exactly predict what people want, when they want it? And if that's the case, if we manage to do that, then we can run a communist society, in a very neat way, totally, right? Now, the reason why the Soviet Union failed was because, first of all, those equations exist, right? And the guy who invented them was trying to run them. but he was trying to run them in the 1970s, 1980s, where the computing technology was not good enough. And therefore, it took a long time for those machines to churn all the data. And by the time they did it, it was just too late. Okay. So it was a problem of having fast computing fast enough to run them faster. Okay. And anyways, it didn't happen. Communism collapses, right? Let's fast forward into the future, into the present, I'm sorry. Right. Now in the present, we have, the democracies, free markets, regulated markets, of course, but freer markets. And then you have China. Okay. And you may have heard of what's called the social credit system in China, where they actually, in fact, spying everybody, they collect data with everybody. Now, the reason why the Chinese do that is not only because they want to control society. This is just one less important reason for them. And the reason why I say that is because there is, the Chinese communists are not hiding why they do that. There are papers out there, the economists talk about that. They're trying to solve the socialist calculation problem. That's what they're trying to do. Okay. The problem that was not solved in the 1970s and 1980s because the computers were just too slow will be solved in the 21st century because the computers are very, very fast. And the way they're solving it is by collecting data from everywhere in China and running AI on it. Okay. And that is what they're trying to do. They're trying to use AI and data and computing and fast computing in order to solve the social calculation problem and be able to predict and be able to run, a communist society from the center. Okay, so that's what's going on there. Now, who's going to win the race? That's the trillion-dollar question, and I mean maybe trillions-dollar question, because whoever wins this race will be the successful economy of the 21st century. Right? They will be able to develop a society that is highly productive, that creates an abundance, essentially. Okay. So my take is that, for better or worse, this technological computing, algorithms, AI, data is a godsend for a communist government. Okay. Why? Because it's by its nature centralized, because it solves for the problems of centralized economy in a very efficient way. And that is why the Chinese government has adopted it. That's why it spends billions of dollars on that. That's why he has sent, all the smart people in American universities to learn how they do it and go back to China. You know the story, right? And right now they are more and more edging towards being more advanced than us. By us, I mean the US and Europe, or let's say the West, in that field. Okay. So the question is, what are we going to do with AI? Okay, how are we going to, take that amazing technology with a cognitive multiplier and forget about consciousness and all the social things, but let's focus on this from an economics point of view, from a utility point of view. How can we use this technology to better our lives, essentially our societies? I mean, how do we do that? I think this is very difficult for a democratic society. And in my book, Cyber Republic, I'm trying to propose ways whereby we can take this very authoritarian technology called AI, right, and apply it in a democratic society where we all need to, have a stake in that, right? We can't allow either the government to become, communist-like and democratic only by name, or big corporations, exploiting our data and running the show. We can't allow that. But that's where things are going currently, Jonathan, right? And that's what worries me quite a lot. Okay, it worries me quite a lot because everything around computing, everything about AI leads to more and more centralization and more authoritarianism, right? So we need to find ways, and there are ways, and it needs citizen engagement in order to do that, in order to be able to participate in the digital economy, have a say in the digital economy, use new technologies such as Web 3.0, and create new forms, new business models, more participatory business models, if you like, cooperatives in the digital economy where we all have a stake. Now, I'm being very, I'm trying to summarize a lot here, right? But anyways, just highlighting the tension, if you like, between a democratic society that wants to use AI and a non-democratic society for which AI is just, great, that's such a great fit.
Right. And you're right. These are really, really big ideas that are affecting everything about life, that have been going on for tens of thousands of years. So we could spend the next couple lifetimes talking about it. So I'm personally excited to see where your work takes you in the near and far future. And for the folks that have been listening, that have had their mind blown apart and put back together again, where should people connect with you to find out more about your work?
So absolutely, I'm on Twitter, unfortunately or fortunately. My website, Jonathan, you have to somehow spell that out to your
It'll
to your
be
listeners.
clickable, I promise. We'll
It's
be able to
definitely
click it.
clickable. It's got a few consonants and a few vowels. GeorgeZarkadakis.com. Yeah, you got it. Excellent.
Perfect.
Absolutely. And if you just Google me, I'm there, and I always respond to sensible people.
Outstanding. Well, I genuinely appreciate you coming on here and let me throw so many weird ideas at you. I was just fascinated by your work, and I'm excited to see what you've got on the horizon too.
Thank you so much, Jonathan. It's been great speaking to you. Thank you so much. Thank you so much. Take
You're
care. Thank
welcome.
you.
So
Thank you.
we'll call that a stuck landing, and I'll let you loose on those burritos. So
I'm going there.
beautiful. I'll give you a heads up when the episode goes live, and I'll have the show notes and everything too. So,
Thank you
dude,
very much, Jonathan. And I'm very interested. We didn't get a chance to speak about your work, so please, send me some stuff, some more stuff. I obviously Googled you and had a look at a few of the things that you do, and I found them fascinating. But I'd like to learn more. So please let me have a little bit more of you as well.
you
Okay.
got it. Don't you threaten me with a good time.
All right. Okay. All right. Okay.
Also, all
Take
right,
care.
George. Thanks.
Take
Bye,
care. Bye
man.
bye. Bye bye. Bye bye. Bye.